Okay, thank you for waiting. And ano ko na hinto? So ito po, no? Once you have this BU and BB matrix, you will need that. Pansinin nyo, BU, BB, if I refer here, so you, kinonvert ko siya sa BC variable and BJ. Okay? Then, so pag na-detect ni SMAT ng BC ay 2, so magpe-prepare siya ng this formula. So that means for 2 by 2, no? Okay, kasi ibig sabihin, pumagal. Say this one. Ayan, this one. Itong 3, 4. Ang magiging location nito will be S11, S12, S21, and S22, right? So basically 4. Etong 3, 1, 2, 4, mapupunta siya sa buong S matrix. So mapupunta siya sa S11, S22, S33, S12, S13, S21, 22, 23, so on and so forth. Okay? Yan. Pag na-detect niya yung ano na yan, yung data na yan. Okay, then that's it. Once you get the S, applyan mo na siya ng formula na P equals SD. Yan. Invert the S matrix. Sorry, so D will be equal to S inverse P. So, invert the matrix, multiply sa P vector, you will get the displacement. Okay? So, kumbaga, in terms of heat problem, you will get the temperature. What else? I also have other lectures sa channel ko, yung gusto ko sana i-discuss. Yung singular matrix, paki-check na lang po yun. Important din siya kasi we know that a singular matrix has no determinant is 0, no? Determinant 0, so hindi siya masosolve. So ang physical meaning nun is instability sa structure. No, for example, if this structure na ito, lagyan mo siya ng konting support. Yan. Say ano lang, say this one lang. Ito lang support niya. Tapos you can have loads here. So marami kang displacement. May displacement ka dito, may displacement ka dyan, may displacement ka dito. And ang ano niyan, we all know that this is unstable. So may instability ka. Okay? Then because your S matrix here, so basically ano yung size ng matrix mo niyan? 1, 2, 3, 4, 5, 6. So that your S is 6 by 6. So ang laki ng size ng matrix mo. Compared mo dun sa fully supported na structure, 3 by 3 lang. Okay? And it turns out this is a singular matrix. So you may check the lecture of that dun sa matrix analysis na lecture. I believe important din siya sa FEM concept, no, because that means if you provided an unstable structure, that will result a singular matrix sa iyong S matrix. And so mathematically you cannot invert, you cannot invert that matrix. Okay. And even sa ANSYS, nangyayari yan sa ANSYS, sa mga hardcore FEM software. You may get that that kind of error, that it cannot get the inverse of your matrix because it's a singular matrix. Okay, next is do we now proceed sa constant strain triangle. Yeah. Okay, so we're now ready for a two-dimensional. Ito na lang. So let's start with the triangular shape. Oops. So let's assume a 2 displacement or 2 degrees of freedom per joint, no? In this triangular shape two-dimensional element. So if you have 2 displacement, 1, 2, 3, 4, 5, 6. So we have 6 unknowns. 6 unknowns. So we can express that by this displacement function. No? So for the u, a0 plus a1x plus a2y. For the v, a3 plus a4x plus a5y. So that is 6 unknowns. Okay? Now in matrix form, ito siya. Okay? Or D is equal to phi times alpha. Alpha, the unknown constants. And then this is our, like tawag dyan, phi, no? Pero sa iba, it's phi, no? Okay? Next is, so in general, if you have, if this is in 3 degrees of freedom, so magkakaroon ka ng W. Okay? So in general, this is the equation. But we only use U and V. Okay? Because later on, we will be solving plane stress. So plane stress, di ba? We neglect yung stress sa z-axis. So we just need a 2D. So that's two-dimensional only. So we only need U and V. Next is, okay. Okay, so U1 is equal to, yeah, alpha. Okay, U1, U2, U3. So we can in-extract lang ito. This one. And this one. Okay. So in terms of coordinates na. We are basically solving this problem in terms of Cartesian coordinates. No? So x1, y1, mga coordinates po yan. Okay. So we can invert that. So maganda rin pang assignment to. No? So prove that yung inverse nito is this one. Yan. Okay. So matagal yan, no? Kaya huwag na natin ano. So if you invert that matrix, so basically this is U is equal to this matrix times alpha, right? So we need to to get the equation for alpha. So invert that matrix and multiplied sa U matrix or the displacement. And it turns out that the inverse of this is this one. If you notice, still constant pa rin to, no? This is constant in terms of coordinate, no? These are all in terms of coordinate. And area of triangle is this one. Bakit? Ito na sulatan. Yeah. So basically, if you have data of all the coordinates, you can get this, the area, and then you can get this one, the inverse. Okay. So that's alpha and u. Now proceed tayo sa second page. Yan. So we can now get the u, formula for u. No, not this one. Dito muna tayo. And first, strain is du dx. Plane stress tayo, no? Strain y, dv dy, and shearing deformation, du dy plus dv dx. But again, kagaya ng ginagamit natin kanina sa derivation nung ano, 'di ba? Nung integral of n transpose f, yung ginawa natin kanina. We set that u is equal to nd. Well, dito sa lecture, on this derivation, u is equal to nu. Yan. Basically, this is displacement. Okay? So u is equal to nu, or u is equal to ni ui. So therefore, du dx is equal to dn1 u1, no, over dx plus dn2 u2 dx dn3 u3 dx, because tatlong ano tayo, no, we have 3 x coordinate. So ganun din sa dv dy, dn1 v1 dy, dn2 v2 dy, dn3 v3 dy. For the shearing deformation, so mas madami siya. So in matrix form, we have this. Okay? We set that b is equal to dn dx. Di ba kanina? So therefore, this whole matrix is the b. Because we get the first derivative of the shape function. Na ginamit natin ito kanina, no, sa derivation nito. Kanina dito. Okay, so strain is equal to BD. Next is, okay. Where's my CST? But we know that the N matrix is, we already know the N. No? Where's the N? This one, no? N is this one. The interpolation function or the shape function. So again, call ano yan, no? Itong x2, y3, mga coordinates. Okay. So we will use that 1 over 2a here. This one. Okay? So, ginamit siya dito. Now, what is, for example, na-paste ko ba siya dito? Hindi ko pa kasi na-paste. Nauna pala yung rectangle. Yan. Okay, so dn1 dx. So kailan so we need this b, right? So dn1 so simplify natin to into this. So if we find dn1 dx is equal to 1 over 2a derivative of alpha 1, which is constant, so 0, plus beta 1x, so beta 1, plus these are constant, so 0. So that means dn1 dx is simply b beta 1 over 2a. Okay? So which is this one. Na-establish ko ba yung ano? N kanina. Sorry, hindi ko pa nakita. Yeah, ito yun. Okay. Okay, for the dn1 dy, so magiging constant naman or magiging variable is this one. So matitira is gamma 1. Okay? So ito magiging 0. Okay? For dn2 dx, so ang variable ito, yung x. So 0 to. So beta 2 over 2a. Okay? So still, as you notice, yung dn matrix natin or the B matrix is still constant. Ayan, constant lahat to. Okay? Okay? That's why we have, so B matrix is constant. We established that. This one. Okay, we know this We get this already. So substitute that to our matrix. We established this already. K is equal to this one, B transpose DB. We know this is constant. This is constant. This is also constant, the D matrix. Okay. So therefore, our K is now this one. Because we are integrating on the volume, volume is area times thickness. Okay, we know the formula of area earlier. Thickness is provided in the problem. Assume ano yan, constant din. So we can now get the K matrix per triangular element. Okay, so applying the formula yung B transpose DB, this one. B transpose D, ito yung plane stress na D along with this. Okay, and then this is the B matrix. You can translate that into our SMAT. So that's why I have this one. Okay, so for example, the problem here is determine the displacement at the node for the following 2D solid continuum considering a constant thickness of 25 mm, Poisson ratio mu as 0.25 modulus of elasticity. So still to, no? 2 times 10 raised to 5. Okay, megapascal. So discretize with 2 CST plane stress elements. So by the way, kaya siya tinawag na CST is constant strain, no, triangle. If you notice here, saan yung strain natin? This one, yan. Ito yung formula ng strain natin, di ba? du dx. And this is the corresponding u. No? Alpha naught plus alpha 1x plus alpha 2y. So yeah, if you find the derivative du dx, which is the strain, you get a constant, alpha 1. Find the derivative of dv dy, another constant, alpha 5. And here, another constant. Yeah. So there's no variation of strain inside the element. Okay? Kaya gagamitin mo lang yung triangular element dun sa mga region na maliliit, no? Na wherein yung strain hindi ganoon ka-importante, no? Pero yung stress importante. Okay? That's why we preferred yung rectangular element. Okay? So yan. So next lecture, yan natin yan. So focus muna tayo sa CST. So establish natin yung coordinates. So I have, okay, here's that. So for example, member 2, 0, 0, and yung 1, 5, yung x nito, this one, and then 1, 2, 3, no? 0, 1, 5, dapat 1, 5 din to. Saan ba ang 0 ko dito? Zero, 1500 and 500. Okay. Zero, 1500. Okay, tama, no? May x coordinates, it's either 0 and 1500. Okay, yun lang, no? For the third. For the y coordinate, I can only have 0 or 500. This one. Anong page pa to? This is page... Page 174. Page 174. Okay, next is, okay, in-establish ko yung ano, yung area. Diba? 1/2 times yung, itong nasa loob. Okay, yung determinant niya. So I got 3.75 times 10 raised to 5. Formula ng alpha is this one. Alpha ba yun? x2y cubed minus x3y2. Share screen ko lang to. Screen mirror. Hindi naka-open ito. And then for x3, y1, ito yung sa shape function eh. Minus x1, y3, then x1, y2 minus x2, y1. Minimize ko para makita niyo. Yan, okay? Yan po. So, x2, y3, ito yon. x3, y2, tapos x3, y1, x1, y3. So, which is yung alpha natin. Then for the beta, yan ito. Minimize. Yan. So, beta 1, y2 minus y3. Yan. Beta 2, y3 minus y1. Beta 3, y1 minus y2. Okay. So gamma 1, x3 minus x2. x2 minus x1. I think this is typo error, no? It should be x1 minus x3 and x2 minus x1. Kasi same sila eh, no? Kinorek ko na lang dito sa code. And for the B matrix, this one, this is the B, and yung constant ano niya, counterpart, is this one. Yan. Okay? Okay, so ito, beta 1, beta 2, beta 3, gamma 1, gamma 2, gamma 3. Okay? Okay? So this one, gamma 1 is here, gamma 2 is this one, gamma 3 is this one. Okay? Okay, next is, so yan, constant yung B. Okay, so from the formula, establish na natin yung B. That's it. Okay. And I only use, nasan yung D matrix ko? Where's my D? Bakit wala? This one. Yan po. So this is the D matrix. I named this as C. Okay. E over 1 minus mu square. Yeah. Okay. So this is the C or the D matrix. Then where's the formula for K? Ayan, so yun lang, no? So thickness times area, so that's the volume, then B transpose, C, and B. So basically, hindi ko na siya tinype in, no? So i-operate mo lang siya, no? After getting the B and the C matrix. So makukuha mo na yung K1. Okay? So that means this K1 is ito. 0, 1500, which is $1,500 and $500. Okay, 1,500, 500. For K2, ulitin mo lang naman yun, no? Yung formula na yun. Yan. 1,500, 0, Yeah. So ulitin mo lang yung formula na yun. Mababago lang yung coordinates. Right? Nabago lang naman yung coordinates. Okay? Because so 1500 0 so 0 0 1500 0 and 1500 500. Okay. So tama, sinunod ko yung ano, sinunod ko yung drawing sa problem. Okay? So this is element 1. So ang coordinate niya ay 0 0, okay? 1500 500. So ito 'yon. 1500 500. And third coordinate 0 500. So this is 0 500. Okay? Then for member 2, drawing natin. So this is 0 0, 1500 0, so, then 1500 500. So ganun yung direction ko. Papunta doon. Okay? Now, so once na copy-paste lang naman yung formula, may establish mo na yung K1 and K2. So we can now establish our S matrix. So dun papasok yung BU and BB matrix. Yan, to generate the S matrix. Okay? How do I show this? So dito na lang ako magdo-drawing. Okay. I think ito na yun. Kaya ako siya sino dito. Yeah, I think ito na. Okay. Palitin ko lang. View. So each element has 2 degrees of freedom. Therefore, 1, 2, 3. So 6 by 6. So our K matrix is 6 by 6. No? As you see here, 1, 2, 3, 4, 5, 6. Okay? And if you check our, bakit 3 by 3 lang to? Okay, 6 by 6. So if you check our K1 here, 1, 2, expand ko to. Expand, that's it. So 1, 2, 3, 4, 5, 6. So yun yung ating matrix. So 6 by 6, tapos saan ang restraint natin? Check ko yung restraint. So may restraint tayo sa node 4, 1, and 2. Node 4, 1, and 2. So ito yung loading. May 25 kilonewton here. Okay. So node 1, 4, and 2. So in my setup here, node 3, 1, and this one. Okay. Medyo magulo yung sulat ko. So ano yung naming ko dito? So yung K1 ko is 1, 2, 3, 4, 5, 6. Ano ba yan? Ulitin ko na nga lang. Kasi dapat maging consistent dito eh. Dito sa BU ko. No? Okay, so ulitin ko which is correct eh, no? 2, 5, 3, 5, 6. Ayun pala. 1, 3, 1, 2, 3. Okay. So, ang displacement ko sa member 1 here, this is, lumalabas ito yung member 1. Ito mahirap sa journal eh. Nadi-disconnect yung ano. So, 1, okay. 1, 2, 3. So, yung naming ko is this one. 1, 2, 3, 4, 5, 6. So, ganyan yung direction. Inuna ko munang lagyan ng node number lahat ng X. Why? Because para consistent sa derivation natin. Naalala nyo yung derivation ng B matrix kanina? Sinetap muna natin lahat ng U matrix. U1, U2, U3, V1, V2, V3. So, hindi U1, V1, U2, V2, hindi ganon. So, dapat consistent. Okay. So, na-establish ko na. 1, 4, 2, 5, 3, 6. Next is for member 2. Ang magiging code mo doon is 1, kasi established na yung 1, 4 eh. Ito. Established na itong 1, 4. Galing dito sa member 1. Established na rin yung 2, 5. Galing dito sa member 1 din. So ito na lang natitira na wala kang code. 7 and 8. Okay? So consistent yan sa sa K matrix mo. So establish na si 1, 2, 3, 4, 5, 6. And then 1, 7, right? 2, X din. Then proceed na tayo sa mga vertical. 4, 8, and then 5. Okay? So, yun yung coding per element. 1, 2, 3, 4, 5, 6, then 1, 7, 2, 4, 8, 5. Now, i-relate ngayon natin yan dun sa may displacement. May displacement tayo dito and then dito. So, which corresponds to what degrees of freedom? 2, 5, right? 2, 5, and pwede kang mag-displace vertically kasi may roller support ka lang dito sa horizontal. 2, 5, 8. Right? 2, 5, 8. So, 2, 5, 8. So, ang S natin will be 3 by 3 kasi you have 3 displacement. Okay? You have 3 displacement. 2, 5, 8. Okay? Now, BU. So, for K1, yan. So, for member 1, ano yung kailangan natin? Diba? 258. 258. Yan yung degrees of freedom na may displacement. So, for member 1, we need 2 and 5. Right? So, address yan, no? Address. 2 and 5. For member 2, 258, no? Saan si 258 dito? 258. Diba? 258. Ano yung address niya? It's on the 3rd. It's on the 5th, yung 8. And then it's on the 6th, yung 5. So that's why it's 3, 5, 6. Okay? So yun yung address dun sa from each K. Okay? 2, 5, 8. So it's on the 3rd, it's on the 5th, and it's on the 6th. Okay, how about the destination? Yan, ito yung S natin, no? 258. Destination. Destination need 2 and 5 dito sa S natin. It will be on the 1st and 2nd. No. It's on the first and third. Kasi sinet up ko siya na 285. No? Yun nga, it depends sa ano niya. No? 285. Sinet ko siya na 285. No? Yung coding ko. Okay, so it's on the third. No? So it should be 2. Ito na nga lang. So si 25 here will be first and third. First and third. Kaya 1 and 3 sa member 1. Sa member 2, it's 285, no? 285. So straight 1, 2, 3. That's why it's 1, 2, and 3. Okay? Yun lang medyo ano dyan. Yun yung crucial dyan eh, no? So that's it. Once you sinet up mo na yung BU and BB, then yan, just paste yung code for generating S matrix, and I have this. So this is the S matrix for the two-dimensional plane stress problem. If you notice, symmetrical siya. So that's one of the property ng S matrix. It's symmetrical in general. No? In general, it's symmetric matrix. Okay. And yun nga, from the formula P is equal SD. So therefore, displacement is equal to S inverse P. So we know S. How about our P? P vector is this one because may applied load tayo sa, diba, this code is 285. No? So it's applied along degrees of freedom 5. Yung 25 kilonewton. So we know the S matrix, the invert of that, multiplied sa P matrix, P vector. So D is equal to S inverse P, and you will have this displacement. Okay, which is sorry. So ito yung sa book. Yan. So, hindi ko na check yan. So basically, this is what we got. Okay, it got 0.606 mm, 0.0156, and 0.0612. So the same naman. Okay, so that's a plane stress problem. Okay. So I will just send ko na lang to sa sa Teams. No? So pwede ko i-send ngayon. Ay kaso copy ko muna. Control C, Control V. Pero send ko pa rin sa Teams. No? Okay, so file sent, and that's it. So next meeting, rectangular na tayo. Ganun lang siya, no? So do you have questions po? So pwede na tayo magpa-assignment ng triangular element, and so parang let's say assume kayo pwede na mag-assume ng beam pero using triangular element. Let's see if you come up with the same displacement. What else? Meron pa bang kailangan discuss? Then kasi mahaba yung rectangular because mag-aano na tayo doon. Mag-numerical integration na tayo doon. Gauss quadrature. Yeah. So next meeting na lang yun. Then, yun na, that's it. Pwede na tayong mag, plate bending after that. Okay? And next is yung ANSYS. No? Let's try ANSYS. Okay, so no more question po. So, thank you for attending and see you next week. Wala bang holiday? Wala naman.